Hello everyone, this is Module 1, Part 2 of Chapter 1, the introduction to the Cronky book database processing. Where we left off, we're talking about components of a database management system, and the three parts that we discussed in detail were the applications, the database management system itself, and then where SQL, or the structured query language, falls in those components. So the applications, again, are the computer programs that the end users work with to connect to the database management system. These applications have to be, well, they don't have to be, but typically these are the functions that those applications are able to do with the database management system, meaning that it will be able to give you the ability to create and process forms for end users to use. Forms are typically used to collect data into the database, so you can create specific forms to collect specific information from that end user, so that you can input those facts and figures into those individual cells that we just talked about in our rows and columns. These applications also help us process queries. Typically, when you're using a application or end user application and you're doing something in that application, when you click on a button or you click next or something like that, typically that processes some type of SQL query that either inputs data or retrieves data from your database, or it may run some specific query to retrieve a combination of information from the database. So the application helps with the processing of those end user queries. Applications also, especially in, like I said, real world or business units, do a lot of reporting where you can create and process reports from data that you've collected. So an example would be if you worked in an organization that sold a particular type of parts or goods, and you needed to process reports on inventory levels or sales or purchasing. Typically those end user applications are designed specifically to create those type of reporting structures. I know in this particular class, again, once we get to Module 2, Module 3, and Module 4, you'll be using SQL Server Management Studio Developer Edition. Within the Developer Edition, it does have some reporting features that you can play around with. So as we create databases, if you wanted to, practice on some of the, data analytics or reporting features of SQL Server, you'll be able to do that. Okay. The last two, being able to execute application logic and control the actual application itself. That has to do with more built-in programming within the application. A typical end-user application is not only going to process SQL queries or SQL language to retrieve data from the database, but it's also going to have some additional programming logic built into the application to help do the different things that maybe your database management system cannot do. Database management systems can't do everything because, again, depending on what you're doing, that application may have to serve several different type purposes. So the database applications or the end user applications that they use to connect to the database management system can be either very broad, where you can do a lot of different things, or they can be very, very specific, so it handles specific functions or needs of either collection or processing of your data. Here's an example of a form that you'll see and actually that you'll create in Microsoft Access in Assignment 1. This form here, notice it's a class form designed to collect information about specific classes, whether obviously we're talking about class number 40, so you're collecting information on the class name, the term, the section, and then the class enrollment data, meaning where you can add additional students to this particular class. So again, this is an example of how you can collect information using a basic form created in Microsoft Access. This next slide is an example of a typical query and what a query looks like. Okay. Notice we have at the top there, we have select from where. In Module 2, we'll talk about the select from where framework more in detail, but essentially what this does as a query, a SQL query is that we're selecting certain columns, which is in your select line, which would be last name, first name, and email address. The from line will indicate which table that you want to select those columns from, and then where is the condition that you want to put on the data that you're selecting. So in this particular example, our condition is we want to select all of the students' information. We want to select the first name, last name, and email address of all of the students from the student table that's greater than 2. Okay, and that condition greater than 2 is, of course, is an algebraic function, but as you'll see, a lot of what we do is based on relational algebra. So what you see in the bottom box there is the results of that query. Okay, and again, this is how it would look in Microsoft Access in regards to if you were able to process that query and how your results look. This is how the results are presented in Microsoft Access. Okay, if you run this same query in SQL Server Developer Edition, how the results are presented will look quite a bit different. Okay. This next slide here is an example of, and again in Microsoft Access, of how your reports would look. Notice here we're able to run the report on the form. Remember the form that we just looked at? If we ran a report on all of the information that may be in the class, a combination of the class, student, and grade tables, notice we can associate all of that information together with a student, a class, a term, and their grade in that particular class. So we know this report actually is a query that's run in the background that produces this report in a way where it may be meaningful to the end user. Okay, so reporting generally is for planning, is for analyzing, is for projecting, those type of things for different organizational units. So Microsoft Access, as well as SQL Server and other database management systems, give you the ability to create and design your reporting so that it fits specific needs or purposes depending on how you use it. So, but this is just just an example of what the reporting features in Microsoft Access 2013 would look. So the database management system is the next part. The database management system and the functions of it is the meat and potatoes of everything that we'll be dealing with here. Obviously, with the database management system, we can create multiple databases within the management system. We can create multiple tables within a database. The supporting structures or indexes that we can create. Modifying the insert, updates, and deletes of database data. You'll hear me commonly refer that as like daily maintenance or daily operations. those transactions and things that happen on a frequent basis. We need to be able to manage those so we can maintain the integrity of our data. So modification is a big part of what database management systems do and help us manage. Of course, the database management system is going to be able to read the database data, so we're going to be able to, so when we store that in a way that we give it a data type that the database management system recognizes, so when it goes back to read the information that is stored in those individual cells, it can read and understand exactly what it is. Okay? The database management system also maintains the database structures. You'll see as this class goes on, especially towards the end where we get into more of the data definition language of our SQL, you'll see how we create the structures of our database based on how we want to build our tables, our columns, our rows, our actual data types. That's how the database management system maintains the structure of your database based on how you pull it together. Enforcing rules and controlling concurrency, backup and recovery, those are all falling in the category of security. There's several different security mechanisms that you can put in place with the database management system. Enforcing rules, some of that you'll hear us talk about referential integrity. That helps us control some of the modifications that if we go back up to the daily operational type stuff. Other rules may be all the way down to maybe a form that only accepts certain characters. So when an end user goes to input data in the database, we make sure that we're collecting the right kind of information. Concurrency and backup and recovery are kind of self-explanatory in regards to how the database management system uses it, but obviously backup recovery is a huge part of security in the case of any type of disaster recovery, disaster type options or data loss, helping us be able to recover from data loss from any type of significant event. So these are just some of the basic, most common functions of a database management system. So by definition in the book, the database or a database is a self-describing collection of integrated tables. The tables are called integrated because they store data about the relationships between the rows of the data. Okay? If we go back to that original slide, remember we created those relationships by common columns. So that's when we talk about relationship between those rows. So each column will have a relationship with another column within that particular database or within those tables. The last two bullet points, the database is called self-describing because it stores a description of itself. That's the reason why it's called self-describing. And that self-describing data is what we call metadata, which is data about the data. Okay? So here's an example of metadata within a database. So we talk about metadata, so if we're talking about metadata on tables, if you look at the top table there, you'll notice here that we have 3 different tables in our database. Student, class, and grade, remember, was our examples. 4 columns, and the primary keys of each table. Okay? This is considered metadata, so data about the data that we're collecting. The same thing with the columns in our table. Notice here we have our column names that are in all of the different tables, as well as the table that it's associated with, and then the data types of those columns, meaning the type of information that the database is going to be allowed to be captured, whether if it's text or numbers or whatever. And then we have data lengths that we allow too. So again, these are rules. The data types are rules that we won't that we have to enforce about our data and about our tables. So in this class, in terms of the context of the chapters, for this particular class, we'll be using chapters 1 through 7. 1 through 7. Notice some of these contents or some of these concepts in this book we won't cover much in this class or be discussing in this class. However, I encourage you to go in and read, chapters 8, 9, and 10 and some of the appendices so you can get the informational data that's on here. But we will touch on stored procedures, triggers, functions, those sort of things. We will talk about security data just a little bit, but we won't go in depth. But again, here is the areas within the book that you'll be able to find that information. So in terms of Microsoft Access, here are the components of Microsoft Access. Notice, again, we have end users that touch specific applications, and that's what's unique about Microsoft Access, is that it's an application generator, meaning like it has a lot of user-friendly application that you can use to create forms, reports, and be able to query informations so that you don't necessarily have to know SQL programming or know SQL syntax to be able to manipulate the database management system. Microsoft Access considered a low-end product for individual use or small business groups. Again, it attempts to hide much of the complex SQL syntax and database technology from the end user, so you don't necessarily have to know a whole lot. And it's good for beginners and those database professionals that, again, are managing small amounts of data. Small amounts of data. For this particular class, most of our examples, or all of our examples, will be using Microsoft Access 2013 as discussed. So what is Microsoft Access? Microsoft Access is actually a database management system plus an application generator. So the database management system, as we already discussed, creates, process, and administers the Microsoft Access databases, and the application generator includes query forms and report components that make it easy for that end user to use. Okay? The data engine, make sure you familiarize yourself with that as well. The Microsoft Access Database Management System engine is called the Access Data Engine, which is different from a enterprise level. So this is unique to Microsoft Access. But Microsoft Access is capable, every Microsoft Access 2000 through 2010 can be used as an application generator for SQL Server. So it can be used in conjunction with SQL Server, obviously, because it's a Microsoft product. So now this is where we start talking about the enterprise class database management system. Notice here there's not a lot of application generation stuff for you. Enterprise class database management systems start getting to specific application interfaces with SQL to manage your database management systems. So it can be all the way from client server applications that are running over a local area network to maybe web applications or web portal applications that help you generate the SQL syntax to manipulate your database management system, or mobile apps or XML, maybe from a smartphone or a tablet or something like that, that can help you generate. But enterprise class database management systems has more ways to interface and manipulate your database management system, essentially. Prominent database management systems, we already talked about Microsoft Access. We will use SQL Server in this class. There's also Oracle, MySQL, and IBM DB2. If we go from a power to functionality scale, Microsoft Access obviously will be on the low end, all the way up to an IBM DB2 type product to an Oracle product, it could be more complex, meaning like more powerful and much more difficult to manage. Typically, those that have the ability to manage Oracle databases or IBM DB2 type enterprise class database management systems have specific skills that are needed to manage those. That's specific to that product. Database management systems obviously can work in conjunction with all different type of operating systems. If you wanted to associate a specific database management system with an operating system, this kind of gives a breakdown here. Notice Windows can deal with all of them for the most part. If you're on a Linux platform, you're really dealing with Oracle or MySQL, and if you're dealing with an Apple OS type system, then really you're limited to MySQL. You got to understand too that database management system products do not run by themselves. They have to run on some type of operating system. So like any other application, they require that the computer operating system installed be able to handle its basic writing and reading, printing and files and whatever other operating services that are needed to run that database management system. Also, too, you have to make sure that you're aware of which operating systems support whatever database management system product that you want to work with. Okay, that's very, very important. And now let's talk about the three types of database design that we'll be discussing in this class. Again, chapters 3 and 4. Chapters 3 and 4 from existing data, database design using existing data. That's where we start getting into the use of normalization. New systems development is where, in chapters 5 and 6, is where we start getting into creating ER data models using ER diagrams, and then from those data models and ER diagrams, we'll create our logical database designs. And then chapter 8, which we won't get into, or chapter 7, in our final project, we'll try to do some implementation or database redesign, meaning like data migration or redesign of an existing database. These next set of slides are kind of a breakdown of the database design that we're talking about. So database design from existing data. We can be creating databases from spreadsheets or text files, or we could be taking an operational database and extracting data from it and creating a new database. That's still considered existing data. Remember, we talked about in chapter 3 and 4, we'll use normalization. So a normalization database design using normalization will decide how we want to store our data. So this is important. Do we want to put all of our data in one table, or do we want to break our tables down into more logical constructions or more normalized tables, so to speak? But we'll again discuss this more in detail in chapter 3. But again, this is a concept of database design using existing data, just how we want to organize and put things together. Database design from new systems development. Again, we can create our data models from forms that we have using, or reports that we've created from stuff that we already have. Understanding user requirements, creating use cases and other organizational type documents that are specific to job processes and duties or whatever we're trying to do. Create those data models and then transform those data models into logical, then physical database design. So that's the concepts for new systems development. And then lastly, the redesign is where we may need to, which is covered in chapter 8, but we will touch on a little bit in chapter 7, is where we can talk about migrating a database to a different database, existing database to a different database design, or taking the combination of a couple databases and redesigning it into one database. So what you need to learn, what you need to make sure that you understand, is from end user to a database administrator. As a database administrator, you need to understand, SQL Server, MySQL, Oracle, the database management system products that you're working with. Understand SQL. From an end user standpoint, the tools that the end user would be using, whether that would be web server or Java applications or client server applications, to any type of web app or web portal type application to manage your SQL. This kind of gives you a breakdown of knowledge priorities. Again, we'll go up to chapter 7 in terms of what's important to you, what will be important to a database administrator if this is something that you want to go on and do in a corporate environment. And it kind of gives you a scale in regards to importance of what you would need to know as a database administrator and also as a programmer. And lastly, the last set of slides here has to do with the history, the brief history of database processing. Notice we go from pre-1970 all the way to present in regards to the history. Understand the history, know that. I wouldn't memorize everything, but I would know, the major concepts in regards to, like early databases, what it started off with, the emergence of the relational model, that's, very important. When object-oriented concepts were introduced, web services were introduced, and then now, the big data type concepts as well. So just understand the history, where we came from and where we're kind of going. So the last couple slides here, we talk about the relational database model. The relational database model is obviously the most dominant database model. All current major database management systems products are based on it currently. The relational database model was created by E.F. Codd, who worked for IBM in 1970. He based it on the mathematical concepts of relational algebra. So this whole book and this whole design is based on examining and explaining that relational database model. Most recently, the NoSQL movement and the big data movement is a new movement. That's when we start getting into, again, the MongoDB, the Hadoop, those type of things here. Those type of applications there, or NoSQL movement, is a kind of a deviation from the relational model, with non-relational data type structures that are implemented. But those type of topics, again, are discussed in chapter 12, which we won't cover in this class. But I would definitely, as a student in this class and somebody trying to understand databases more, understand what that movement is and where we're going. Okay? So this is the end of chapter 1.